Welcome to another Great Car Basic training session. My desktop. I've just taken a copy of that off of here. I'm going to go into SynWrite, and then I'm going to create a new project and just put it into there. I'm going to save that as training 9A. Okay, so this program is the one that was doing the rotation yesterday, and we can see that on the in the lab. If I just compile it up, it will give us. It goes north. It's going north to south. The LEDs, as you can see. Okay, let's just pull that down a little bit. There we go. Zoom in. There we go, north to south. And how it's doing that, if you remember, pretty simple stuff. We've got a variable that is our state engine. And we create a state engine, and then we test against that state engine, and we set the LEDs accordingly. So for this today, we are just going to flick this around into a more sophisticated program. And the first thing we're going to do is we're going to change this LED state into an integer, and that will become very obvious why we need to use an integer. And an integer can essentially hold negative numbers. Just keep it as that for the time being, okay? Don't worry about the range, okay? We're going to have a new variable, and it's going to be called direction. That's also going to be an integer, okay? And we're going to set the initial value of direction to a minus to 1. How about that? Yeah. So that we're going to carry on what we were doing yesterday. So we're going to the initial state is going to be 0 in here, but we're going to take out this. We had it forced to go through the steps here. We set the LED state, hard coded it. Let's make it a bit more dynamic. So what we're going to do down here is we're going to say the LED state is set to the existing LED state plus the direction. And that means it's going to increment by 1, which is fine. It will increment by 1. It will go 0, 1, 2, 3, and the LEDs will flash. But the problem is that once it becomes number 4, it will then become 5, 6, 7, 8, 9, 10, etc. So we just need to constrain that. So it's if the LED state equals 4, then we're going to put the LED state back to 0. And we might as well do the other bit of code whilst we're here. In reality, no, we'll just do it. We'll just do one at a time, okay? So what we're doing here is saying increment the LED state by 1, and if it becomes 4, set it back to 0. Okay, let's just see what happens. We should be able to maintain what we were doing previously. 1, 2, 3, and back to the start. North, south, a north to south movement of the LEDs. Great. What would happen if we set the direction to -1? The problem is at -1, not a lot's going to happen, to be quite frank, because it's going to be a bit chaotic. So, but we'll do that. But what we need to do is just say to it down here, if the LED state is -1, then set it to 3, and that will then set the reverse direction, because the first time it comes through, the LED state will be 0. It takes 1, nothing happens, it passes through to this if statement here, and then resets it back to number 3. And we should now see it go in the opposite direction, south to north. Fantastic, look at that. Now, going back to where we were the other day, we know that we got a switch, and look, it's down here, look. So we can say things like this now, look, we can say, if the switch is equal to 0, that means it's depressed, then we'll do an end if in here, okay, straight away. Well, if the direction equals to 1, we know then to reverse it, okay? And we're just going to say end if. So we know to reverse the direction, if it's set to 1, we'll set it to -1. And if it's equal to -1, we'll set it to 1. So it should rotate around quite nicely at the moment. And we'll just set that go. So we're going 6 minutes, and we've got the LEDs going south to north. Let me just push this here. And what's happening here is quite interesting. This is a debounce problem, look, because the debounce problem is getting stuck. I'll explain why it's getting stuck now, because we need to ensure that the switch is released. So I'll wait a quick debounce, wait while the button is pressed. Okay, now this is quite clever, because now the moment the button's pressed, it will change the direction, and it will wait now until it's lifted. And it's a very easy way of ensuring that you've got a debounce on a button. So you just saw a debounce problem there. And now it's working, because what was happening before is the button was always down because I had it down, and because it never let me, I wasn't releasing it, it was just changing the directions automatically. Look at that, it's really simple actually, very, very simple. And now I've got the button down, look, I let it go and it changes directions. It's going south to north, push the button down, now it's going north to south. It's working. So how will we do the same using an interrupt? Interrupts are scary stuff, okay, but not really. Let's just save that as number 9. Great Car Basics, pretty simple at doing this stuff, so let's just comment out this here, because we're going to use the interrupt to help us set the direction of this switch, okay. All right, so I just commented out this bit of code here, look. So at the top, I'm just going to add in an interrupt handler, okay? Put it in here, that would be fine. On interrupt is our command. You can see here, and if I press F1 and show you the desktop, I get the help for on interrupt. And in on interrupt, I've got a list of interrupts I can capture, okay? And the one I'm going to be using is if the port changes. Now the port is, remember, port is where the switches are attached to. So port change, I'll take this one. No, port change, any port changes. Now we use this one, okay. Well, the syntax is quite simple. On interrupt port change, I need to call my handler, my interrupt service routine, my ISR, okay. Then I'm going to create a subroutine. It's the first time we've seen a subroutine. We're going to keep it pretty simple, and we start it with the sub, and end sub is the end of it. That's the syntax, and it will then, once that event occurs, once the port changes, and the port changes a change of state on my switch, it will call this routine. Well, Great Car Basic handles an awful lot of this stuff for you. So in the background, it's going to set it all up. So what we're going to do here is lift this code from here and paste it into my ISR and get rid of the comments. It's the same code. But the beauty here is it's going to happen at any time when I push that switch. Whereas before, it was only happening at the bottom of the this piece of code. Let me explain an interrupt. My analogy for an interrupt is quite simple. I'm in the kitchen. I'm cooking a meal. I'm merrily doing my stuff, creating the pastries, adding the stuff, okay? And the front doorbell rings. I stop what I'm doing in the kitchen, walk down the corridor to the front door, open the front door, and I service the postman. I service whoever's there. I close the door and I go back to the kitchen and I carry on exactly where I left off. The important thing is the state was all very controlled in the kitchen. Nothing changed. In Great Car Basic, we look after the state for you. So using an interrupt is relatively simple. The program is running, the interrupt fires, it goes into your routine, a handler, and then you return back to where you were. So we can leave it like that. I think that's adequate. But the problem is, it's not a problem, is how do we know it's the front door, not the back door? Well, if we look at the data sheet for this particular part, open the data sheet. I'm going to the web here. I'll open the data sheet. The easiest way to find this stuff is the following. Control F, IOC, interrupt on change. Look, IOC is everywhere in here. Look, IOC, IOC, that means that these ports support IOC. How do they support it? Look, bigger the chips, IOC, IOC. And then you'll get to a page number where it says where it's defined. And it's quite important that we get to that page. A quick way of finding it is take one of these here and put that in. IOC, interrupt on change, AP. There we go, look. Page 156. It says that the bit called IOC AP, or here's another one down there, IOCAN is a negative interrupt, a negative interrupt. We want a negative interrupt. So if I set that bit to 1, it will fire our interrupt for us. So I'm going to go back into our source code in here, and just below here, it could be anywhere. I'm just going to say set that to number 1, because remember we've got on switch is on pin 3. Okay, we know that, so we set it up with a port on change, call my ISR, and down here that's fine. Do I need to set anything else? I'm thinking. Do I need to clear a register? Well, I'll have to look at that in a moment. Let's have a look what happens. We'll just compile that up. LEDs are going north to south. Get my little pusher here. Hold that down there. Push. And look, the LED is stuck. It's stuck in our ISR routine. Now, the thing about this is we need to clear a bit. Look, it is absolutely stuck on that LED there, look. Because in our LED, we need to clear a flag, okay? We need to clear a flag to say that interrupts occurred. If we go back to the data sheet, we can see it's explained in the data sheet. Look here, interrupt on change for a negative pin going, edge, IOC, AFX, and where X is 3, will be set on detecting that edge. So the key here is we need to unset it to make sure it exits our routine. So in our routine here, we have to, that's not the variable I'm looking for that one. I've just pasted that in, and I'll change that to number 3. So this is very similar to the one at the top, but this says, this is my flag that the event has been serviced, okay? Now when it's been serviced, I can then make it work for us. It's going north to south. Now it's going south to north. And I've still got the button down, which is interesting, because the event has occurred once. I let it go, it doesn't really matter. I push it again, and the moment I push that button, the LEDs rotate in the other direction. Push, and we can see it works because it exits into the interrupt service routine at any time, changes the direction, clears the flag, and then returns back to flashing the LEDs. So we can remove this code here. We don't need it. We could change the delay here by saying wait AD. We're going to read the AD port. We can just change that to where we were before. It's ANA 0. And then we can have this thing rotating at high speed and low speed now. Okay, so we've really made some quite big changes to this program. Look, I can rotate that. We can make that flash quite quickly. That's the I'm reading the value from the digital port, push it, and I'll just slow it down a bit. It's changing direction. Push, push, and interrupt routine. So today I wanted to show you how to use interrupts. I think I've done that.